And hello, welcome everyone to this video of C++, rather OpenFOAM C++, not just any C++. So it's a OpenFOAM video. So last video we actually went through some templates, okay? And we just did an example using, we made an empty class here and we made two constructors that just prints line of code. And of course, it has the ability to analyze lines of code. Now, and one of these constructors was I mean, you can declare it the constructor by giving it no inputs, or you can give a constructor giving it one input. All right, so okay, just want to continue adding on from there. You will have noticed, okay, inside some of these, some of these kind of templates, you can put two templates and not just one template. Okay, I'm not going to go too much into that, but I hope you can try that yourself. You can actually put one template within the other, as you can see in the class fvMatrix. So you see this template belongs to fvMatrix, and this template actually pertains to this little what do you call it? This little what do you call it? Yeah, this little function over here. Okay, so you can actually you're supposed to give this thing two types of some sort. Yeah. Okay. Anyway, I won't go too much into that. This is just basically the same stuff. You do templates one within the other. Okay, but of much more immediate interest is the fact that we can actually have two constructors. Okay, two constructors. So these two functions are of the same type, the same name. See, this thing is called print class. This is called print class also. But one of these functions takes in no input, and you just say constructor declared. One of these functions takes in a what do you call that? It takes in an input of one type. Okay, it takes in an input of one type, and it gives you another kind of output. So if you were to run, QA, okay, if you were to run our sandbox code, okay, wmake there. Okay, if you were to run our sandbox code, okay, you would see this part saying you give me data of type something, and then this part says constructor declared. So there are two constructor functions being run depending on how you declare your object. Okay, why is this the case? Because we coded it in such a way that the same function here, the same constructor function, okay, responds differently depending on how many inputs you give it. So where's our template demo? Yeah, so you can see our constructor, if you give it no input, it will just print constructor declared. If you give it one input, it will print this line of code saying you gave me data of type ... and then you will print the data type there. Okay, so that's two things, right? And okay, let's say I give it a third. Okay, maybe I'll not give it a third class thing. Maybe that's overkill, right? Yeah. So what is this called? Yeah. So you have the same function, but depending on how many inputs you give it or what the type of inputs you give it, it will differ in behavior. This is something in C++ known as polymorphism. Okay, polymorphism. It's a very scary word when you first hear it. It's like, what is this? It's just basically saying the same function will behave differently depending on what input you give it, and you can code it in like that. Okay, so this is example of polymorphism in an OpenFOAM constructor, and we actually demonstrated it in the last video without actually saying what it was. So if you don't know what polymorphism is, now you do. Okay, It is basically the same function behaving differently depending on how many inputs you give it and what types of input you give it. Okay, so this is polymorphism. Okay, so as you can see in fvMatrix over here, you'll see that there are very many different constructors. Okay, so if you have this constructor with two constants, one is a geometric field, the other is a dimension set, it will run one set of code. If it's this, if you just give in an fvMatrix, okay, it will construct as another type. Another set of code will be run. If you construct it as this TMP thing, okay, TMP, I'll not go into it this video yet, but just treat it as a different sort of data type, okay? Treat it as a different sort of data type, or different sort of different sort of data type. So, and then this one actually gives in a geometric field, and of course this I stream, input stream, meaning to say it's reading it from an input file. Okay. Okay, let's vim again. Let's go to constructor. Okay, so all depending on the different sorts of inputs that you give it, this different codes are executed. But basically, they're all the same function. They're all the same name of the function, but they take different forms. So they call this way of coding this function polymorphism, because the same function will behave differently depending on the kind of inputs you give it. Okay, hopefully that clears up why this thing is coded and what polymorphism is about. Okay, if you know this already, of course, good for you. I'm just wanting to explain it for people who don't exactly know all this stuff. Though, of course, I kind of expect a little bit of experience in C++, but at the very least, you should have watched my introduction to C++ OpenFOAM videos. So I did not discuss polymorphism there. So yeah, so I actually try to introduce it here. Okay, so I'll just introduce polymorphism here. Anyway, so moving on, let's also talk about destructors. Okay, destructor is just a line of code that is run there when the code finishes running. So okay, with destructor you will see this twiggly line here, and at least in this case it's declared as a virtual function. I won't go through what it is in this video, just treat it as a function. Okay, but yeah, so virtual, it's a bit like when we discuss inline, it's just like a modifier thing, but otherwise this thing, just treat it as another function that is run in a slightly different way. So of course you won't see the contents of this function here. You will see the contents of this function in fvMatrix.C, if I'm not wrong. Let's go look for the destructor. fvMatrix. Okay, see fvMatrix. Okay, grep-r fvMatrix. There you go. See, it's in fvMatrix.C, fvMatrix type, and fvMatrix. So let's go fvMatrix.C. I don't know where that is. The constructors are defined here. So this is what the constructor does. Okay, the bulk code of constructor, and you can see it. It's not like what we do over here. Here we actually declare the function as well as put in the code what the function does. Okay, normally if the code's very big, you declare the function in the H file, and you tell the compiler what the function does inside your C files. This is the way OpenFOAM is being coded, and most most code is being coded like that. Okay, so let's go to the place where you find destructors. Okay, so see the destructor. So this is how you actually define the destructor. Okay, again we use the template thing here. Then we use the namespace followed by the function name. Okay, and then you go. Okay, you tell that in this namespace, this function within this class behaves like this. Okay, so basically this destructor will delete every single delete some information. Okay, this is part of what they call memory management, but I won't go into it here. Okay, long and short of it, destructor is just a piece of code that's being run after the whole if you finish running your code. That's the long story short. Or rather, when the object, okay, if you declare an object in your environment and then you delete the object, then the destructor is run. So let's see how destructors are, what's the formatting. Okay, so destructor is over here, and then remember, okay, over here there are two lines, before and after. Okay, so when you see this class name fvMatrix, okay, there should be two lines, not one line. Let's just do some formatting, proper formatting. Oh, let's read properly. I inserted the line at the wrong place. Okay, so yeah, okay, between class name and constructors there are two lines. Okay, between public and constructors there's one line. Okay, this is a little bit, yeah, a lot of things to do. Okay, anyway, let's go. You can see here between this function. Okay, don't worry about the TMP thing. This is basically putting in a class, and you see this function being run. Whatever this is, don't worry about it now. Okay, there are two lines of spacings. So one line, two line, and then you can have four spaces in 1, 2, 3, 4, and then you put your destructor here. Okay, let me just check where your destructor is. Okay, class. This is the class fv solver. You open and close here. Okay, your class fv solver is open and close here. Let's see where the constructors are. Yeah, constructor, and then you have fvMatrix here. Okay, then the destructor. Okay, and destructor is also the same. Okay, two lines here. One cell of indents in. So this is four spaces. So you just put dash destructor. That's how you format it. Then you can of course put the virtual there if you want, but I'm not going to put it. I'll just put print class, open and close. Then four spaces in. I want to put the code in here. I'm not going to put it in another place. I'll just put it over here. 1, 2, 3, 4. Info destructor declare. Okay, so every time you finish and you want to start deleting this print class object, this line of code will run, and then you just say destructor declared. Okay, so just show you what it's like. wmake here. Okay, and you run sandbox 2. You can see that you gave me data when we declared two objects. Okay, when we declared two, let's do the sandbox. Oh, sorry. Vim sandbox2.c all the way down. When two objects are declared of type integer. Okay, two objects are declared of type integer. One is object 1, one is object 2. So two constructors are run. Okay, two constructors are run. Okay, vim sandbox2. Oh wait, rather I'll run sandbox2. Okay, so the first constructor is run with we give in data of type integer. The second object is declared, so the constructor is run without any input, so it will just print the code constructor declared. Then once things are finished, okay, once things are finished, what the code will do is to delete everything. It will free up memory, so it will delete everything from RAM, the random access memory, because you don't need the memory to store variables. Okay, so if you declare an object, that object will take up some memory. Okay, it's a bit abstract now, all this memory management stuff, but yeah. So just imagine like in let's see. Let's go on GIMP. Okay, let's give you a little bit of an intro into memory management. So okay, imagine yourself in Python or MATLAB. Those are more friendly codes. Okay, so let's say you declare an array, and inside there's like 10,000 elements inside. Okay, you declare an array. A equals to array of 10,000 9 pieces of data. Okay. Okay, so let's say you only need to use A in one part of the code. So in your code, you will run A equals some addition. So add A and B, right? Something like that. Okay, A and B. So you can say C equals to add A and B. After that, A is not used again. Okay, you may have a while loop. You have some code loops here. You have everything that happens, but A is not used. Okay, A is not used. This array is not used. And this thing here, maybe each of these elements of the array may take up some bit of memory, because the code needs to remember what's the value of each of these 10,000 elements. So let's say each memory, each of these elements is 64 bits. Okay, you may know there's a 8-bit data, 32-bit data, 64-bit data. Let's say this is actually 64 bits, and one byte equals to 8 bits, if I'm not wrong. Okay, 64 bits. Okay, this is also known as a double. There's a double variable, double type. You know, double type variable, when you have decimal numbers, and you see this thing called double type. Yeah, this is what it means. It will take in 64 bits of data, or at least 8 bytes. 8 bytes. 8 bytes. 8 bytes of data. Okay, minimally each of these numbers here will take 8 bytes of data. So well, for 10,000 members, 10,000 numbers, maybe this will take 80 KB, 80 kilobytes, right? That's not a lot, right? In today's standards. Okay, let's make it bigger. Now let's have 10 billion. Let's say there are 10 billion numbers, right? Okay, how many bytes is this? This becomes 80. Okay, that's 80 GB already. That's way too big. Okay, maybe I'll do 80 million, right? 80 million or 10 million, because if you have a very high fidelity mesh, okay, that's the minimum amount of numbers you may encounter. A typical number you may encounter. How many bytes is this? This is becomes this becomes 80 megabytes, right? 80 megabytes. All right. And you just add this. Okay, you may not just have one array. You may have like hundreds of these arrays. So maybe maybe you have 100 of such arrays, right? Because you have, let's say, temperature, volume, density, etc., etc. Maybe you have 100 of these arrays, and then you have to take account in all the mesh array as well. So 100 of these 80 megabyte arrays, that's 8 gigs of memory. Okay, 8 gigs of memory. Okay, I'll give you a give or take thing. All right. So let's say you only use this A once, this A array once, and then you have this loop that takes like what 100 minutes to complete. And for the rest of the time of this program, A is not used at all. Okay. Oh dear. A is not used at all. Okay, for the next 100 minutes. So what do you want to do, right? This A is actually taking up maybe 80 megs of memory. And what do I want to do? I probably want to delete A, right? I want to delete A before I start running my loop. Okay, I want to delete A and I want to free up 80 megabytes of memory. Okay, for example. So because you don't really touch A anymore after this line of code is being run, and then when you run this loop, this A is never referenced again. So once you're done with A, technically speaking, you want to delete A to optimize your code, make it use less memory, and make it maybe faster. Okay, so this is what we call memory management. And this is called memory management, because I don't want my RAM to remember A anymore. I don't want my RAM to I don't want to use RAM to remember variables I don't need to use. So basically, delete variables that are not used. Okay, and there's a whole philosophy, not philosophy. There's a whole topic into memory management to optimize code. Okay, and what a destructor does, okay, part of it is that when you start deleting objects, remember we want to delete anything that is kind of useless after a while. We don't just want to delete variables. Okay? Objects also take up memory. So we may want to delete objects once they are done with their use. So we want to delete objects after we are done using them. Okay, so that's the idea behind memory management. We don't want to use up unnecessary memory. So as soon as we are done with the variables, we are done with the objects, we are done with the function, I want it off. I want to delete it. Okay, this is the gist of memory management. Okay, and destructors are there to help you delete any bits of data that are associated with this object. Okay. Okay. Let's take a look at the destructor. Okay. See, over here, say destroying fvMatrix for field. Okay. So this is what the destructor does. Okay, once you start deleting the object, the destructor will delete the fvMatrix. It says destroying fvMatrix of field. Then it will delete some variables here for this PTR, which is called pointer. Okay, but basically it's just deleting bits of data that I don't need, so I can save on memory. And so that for very big files that I want to run, I don't need to use excessive memory. And that's the role of a destructor. Okay. Anyway, I kind of overrun a little bit, and yeah. Normally, yeah, destructors. Just want to say destructors are this kind of code that are being run at the end of the thing. Okay. So, well, I think I kind of overspilled time again, overrun my time. So, what what have we gone through? Yeah, basically it's polymorphism earlier, and what's a destructor, okay, and what's their role, at least in the context of OpenFOAM, as you can see here, is to delete stuff that I don't really need to use. Okay, so that's what we are dealing with here. Okay, so yeah, I think I'll stop for now. I don't want to overrun my video's timing, and I'll see you next time. Okay, bye bye.